Alright team, exercise 4E. We're now going to look at area of a circle notes. I'm going to get you to copy this down. The formula for the area of a circle is pi times r, which stands for the radius, squared. Okay, and then that's the year 8 formula. I'm giving you a year 9 formula now. Year 9 is that they add on the partial circle. So, like yesterday, we have theta over 360. Okay, that just means which part of the circle do you want? So, do you want all 360 of 360? Or do you want half of it, which is 180 out of 360? Or do you want 270? Because in year 9, they will do different types of partial circles. They don't just do halves, they don't do just quarters. You can get more. So, knowing that formula is helpful. Again, the angle of theta is in degrees. What's this? The angle of the circle. That's weird. I'm just going to write here in degrees. Now, again, just a reminder, we know radius is from the center to the point outside of a circle. Okay, so it's quicker to measure the diameter just knowing the radius. Quick reminder, what is the diameter equal to again? If you know the radius,
It's times by 2.
Beautiful, double it or times by 2. So twice the radius equals the diameter. That's just a note to remember. Some other common approximations. When they say approximate, then you can use 3.14, or sometimes they'll tell you to use 22 over 7. But if they don't say it, you have to use the symbol on your calculator. Okay, so you must find that symbol on your calculator. Let's do an example. Here we go. Let's look at this example here. Find the area of these circles. Correct answers to 1 decimal place. So here we go. Let's look at this circle in the first example. A. What's the radius in this one? Can I please have, let's go with Nick. 4, very good. This is a radius. So we know that radius is equal to 4 centimeters. What is the diameter equal to? Let's go with Zara Jones. What's the diameter equal to? If the radius is 4, 8. Beautiful. So we know it's 8 centimeters, but in the rule that we know for the area, it's pi r squared. So you don't actually need the diameter. It's just teaching you how to read the circle. So according to this formula, we can see it's pi times the radius, which we know is 4. So it should be 4 squared. Now remember, 4 squared is not the same as 4 times 2. Okay, 4 squared is not 8. 4 squared is equal to what? Can I please have Willem? 16, because 4 squared means 4 times 4. Okay, so if on your calculator you can't find 4 and that button to do power of 2, okay, then you can also rewrite it as 4 times 4. All right, so on your calculator, if you don't have the power button, you can do pi times 4 times 4. That means the same thing. Okay, but don't confuse 4 squared as 4 times 2 and write 8. 8 is wrong. Next part. I'm still missing, well, how much of a circle do I want? Do I want half a circle? Do I want 3/4 of a circle? Or do I want the area of a full circle? So based on this shape, how much of a circle do I want? 360. I want a full circle. So when I'm talking about the area, I actually want the area of the entire full circle. So it should be 360 degrees is what I want out of a total of 360 degrees. Okay? So type that in your calculator. Get out your calculator and get it ready. 360 over 360 times 360 over 360. Let's see if you and I get the same thing. Here we go. Get out my calculator. You can do pi. So find the symbol. Pi. Oops, that's the wrong one. Pi times 4 to the power of 2 times 360 over 360. You should get, hands up if you got 50.2654. Hands up. Did you get the same answer? Check your calculator, make sure it's the same. Again, you could have got pi times 4 times 4 times 360 over 360, and you still would have got the same answer. Okay, so as long as you're doing the squared, it should be the same thing. Okay, type and double check that your calculator gives the same answer. I'm just going to write the answer down. So 50.2654, 50.6254, and don't forget to write the area in squared units, so it's squared centimeters. But even at this point, you're still not getting full marks. Why? What have I done wrong? Very good. It says correct answers to 1 decimal place. If you don't correct in 1 decimal place, I will penalize you. So it must be the next answer to 1 decimal place. What is that, Ryan? What's my answer to 1 decimal place? Very good. So it should be 50.6 squared centimeters. That's what I want to see. Okay, so it said correct the answer to 1 decimal place. Make sure to read your question. Sometimes they ask for 2. Let's try the next example. So I've got the solutions up there for you to copy. Next example, notice the question. It says use the approximated value of pi equals 22/7. So in this case, you do not use the symbol pi, but you actually use 22/7 as the approximation for it, not 3.14. So for this circle, now I've got this new one in B. What is the radius for this one? Can I please have, let's go with Hamza. What's my radius? 7/2. Beautiful. So radius is now 7/2. And what is my diameter? Let's go with Yi Chen. It's a bit tricky because it's got a fraction. 14/2? 7. Very good. So another way of thinking about it, you said double the radius gives you your diameter. So you can think of it as 7/2 times 2. Now it depends on how strong your multiplication of fractions are. Back in term 1, multiplication of fractions, top with top, bottom with bottom. So you can see 7 times 2 was where Yi Chen said 14/2. But then 14/2 just means 14 divided by 2, which is 7. But even if you didn't know that, you can kind of work with decimals as well. 7/2 just means 7, half of 7. So that's 3.5. And double of 3.5, we all know it's 7. So that's another way to figure it out as well. Okay? All right, so I know the diameter is 7, radius is 7/2 or 3.5, but I only need my radius. So here we go. We don't use the pi button. We use 22/7 times the radius squared times, in this case, I want a full circle, so it's 360/360. Write in your calculator, 22/7 times, now the radius squared, you can either change it to decimals and write 3.5 squared. I'm going to use 7/2 squared, just so that those who are using calculators, you can learn how to use your fraction symbols too. Times, and it should be 360/360. All right. So how do you do this on a calculator if you want to include the fractions? This is another way to do it. If your calculator can't do the template where I can do 22/7 like that, if your calculator can't do that, you can do it this way. Open brackets, 22/7 means divide 7. So you can just write 22 divide 7 times, the other one is 7 divided by 2, or 7/2. So I do the same thing again. Open brackets. 7 divide 2. Power of 2. So that means 7/2 squared. Times. And if you got 360/360, you can do 360 divide 360. But notice how I'm using the brackets to separate the fractions apart. That's another way to do it if your calculator can't do a fraction template. Okay? You should get the same answer as if you were putting it in fractions. Okay? So that's how you do it. So you should get an answer of 38.5. Can I get a show of hands who got 38.5? Good. Double checked. Good. Excellent. So it should be 38.5. Don't forget the units, and it's already correct to 1 decimal place. So far, so good? Okay? Flip over the page once you've copied the notes. We're going to work on a bit of partial and problem-solving questions as well. So you've done ones where I've given you the radius, I've given you one with fractions. We flip over the page. Now we've got a partial circle. So it's not a full circle. Same thing again, the rule for the area of a circle. What is the rule again? Let's go with Jacob. What's the area for a circle? Good. Very good. Don't forget this next bit. So if you have a partial circle, this is where the theta is important. So in half a circle, what's the angle in half a circle again? Half a circle, because with full circles, 360 degrees. So if you have half a circle, it should be 180. Very good. So we know we only want to color in 180 degrees of the 360 degrees. Okay, because remember there's a full circle, so usually it's 360, but we're only covering half of it. So it's only 180. So your calculator, you should have 180 over 360. We know that's a pi button because it doesn't ask you to approximate. But what's my radius? Looking at this diagram, what would the radius be, Nick?
Is it 6 kilometers?
Very good. Why is it not 12 though?
Well, because 12 is the diameter.
Very good. Very good. And some students will miss out on that. They think it's the 12. But if you try to picture it as a full circle, you can see this point to this point, and it crosses through the center. That's actually your diameter. So your radius has to be half the diameter, which is 6 on both sides. So being careful here, this is actually the diameter, and you know that the radius must be 6 kilometers. So in this case, it should be then 6 squared. So once you've got all the information correctly, now type on your calculator, pi times, so here we go, I'm going to do it again, pick the symbol pi. Whoops, that's not pi. This is pi. Pi times 6 squared times, and in this case, I don't want 360 out of 360. I want 180 out of 360, which is half. And you should get 56.5486. So I should get 56.5486 squared kilometers. And usually they should ask you to round to a certain amount. If they don't say it, the general amount is 2 decimal places. Okay, so if they don't say it, just as a general rule, but the questions I create for your test will tell you exactly what to do. Okay, so I would leave my answer to 2 decimal places usually. So it should be 56.55. Very good. 55 squared kilometers because this is 5 or more. Okay, so if you round it to 2 decimal places, you check the third digit. Is it 5 or more? If it is, you round up the last digit by 1. Okay? Very good. Let's do a bit of problem solving. How do you do this problem now? So I want the area of the shaded region, which is this bit. So I don't want the square. You can see there's a square here because it's got the dashes. The square would give me the entire region, but I don't want the entire region. I only just want part of the region. How do I find the area of this shaded region that I'm coloring in green at the moment? How do I find that specific region? Anyone got some ideas? Hands up. Belinda. Okay. Beautiful. If you weren't able to follow what Belinda was just saying just now, let me illustrate it to you. So Belinda said, well, you only want part of the square. So what you do is you find the entire area of a square. So I'm coloring it all in blue. And then what you do is minus that circle. Can you see this is actually a quarter of a circle right here? Actually, I'll do it in yellow so you can see. This is a quarter of a circle. Right there, if I did the full thing, it would have been a nice full circle, but that's only just now a quarter of a circle. So if you took that away, there's still that left over. So you find the entire square, then cut out the area of a quarter of a circle. So this is called problem solving, where you're applying all the formulas that you've known so far. Squares, rectangles, parallelograms, kites, rhombus. You need to be able to figure out, well, how do I get to the answer I want? So in this case here, you need to first find the area of a square. So let's find out the full area of a square. So area of a square, what's the formula again? Let's go with Eknor. What's the area formula for a square? Very good. So it'll be length times the width, but in this case, the length and the width are actually the same. So it'll be length times length. Once you find the area of the square, we're going to then minus the area of a quarter of a circle. So I'm going to minus now the quarter of a circle. What's the area formula for a circle again? Let's go with Hamza. What's the formula for the area of a circle? Good. Pi times radius squared is the area of a circle. But in this case, we don't want a full circle. We only want a quarter. What's the angle? What's the angle if it's a quarter? What was that? Sarah? 90. And you can see here in this little box, they already hinted to you that the angle this makes is 90 degrees. So I don't want 360 degrees. This is only 90 degrees of the circle. So the formula would then be times radius squared and make sure it's 90 out of 360, which actually just means a quarter. Okay, so I want you to understand that that 1/4 actually comes from the fact that it's 90 degrees out of 360. So that next year, when you get angles that aren't quarters, 3/4, or halves, you can still do. So I can give you a circle with an angle of 196. So I might say something like this. So that's about roughly like that. And if I say, find the area of that shape, if the angle that this makes is 196, find that angle. So that's what you do in year 9. In year 8, we do full circles, quarter circles, and half circles. So I'm giving you a formula to work with any angle. All right, so just try to relate, where did the quarter and the halves come from? They come from knowing the angle. Okay? All right, let's put it all together then. So L times L is your width of your square. The square is 7.2 times 7.2. That's for the square. Then you take that away, or you take away the area of a circle. So you now need to calculate, what's the area of a circle? It's pi times, now be careful, what's the radius? What's the radius of this quarter circle? No, radius. 7.2, can you guys see this is the center, and from here to here is actually the radius as well. This is also a radius. Yeah, so it's hard to picture, try to draw the full circle, you might be able to see it, but the radius is actually 7.2, so it should be 7.2 squared, and then 90 over 360. Now that's a lot of things to type in. That's why writing out your solutions and thinking is important. Yeah, working them at a step-by-step vertical process allows you to problem solve. That's one of the skills that we try to train you to do. Yeah? Let's do it slowly. So here we go, 7.2 times 7.2. You get 51.84. So this is 51.84 for the square. Minus, let's work out the circle. The circle was pi times 7.2 squared, so radius squared, times, and I wanted 90 out of 360 degrees. That gives me 40.7150, so 40.715. Now, I'm going to show you something that I don't want students to do, especially getting in the habit of doing this. I'm going to show you the proper way of doing it, ideally, okay? I want you to see something here. When I type in the calculator, so far it doesn't look wrong, right? I take 51.84 and I'm taking away this answer here. So I type in what I wrote. I've got 51.84, take away 40.715. So here we go. 51.84, take away 40.715. I get 11.125. That doesn't look wrong. But at year 12, this can be wrong. And I'll show you why. You see, if I actually took the real numbers, if I actually took the numbers, and then I said take away this one, actually that's not the one. What was it again? Is that the one? No. Whoops. I was meant to take 50.84. Sorry, my bad. So the square, take away this answer. What's the difference between this answer and this answer? Yeah, it's 124. If I round it, it is 125. But what if they said round to 4 decimal places or 5 or 6 decimal places? I can be off. I'm off just by a digit. So at year 12, that 1 digit difference makes a difference. So where did I go wrong? This step. At this step, don't round your answers in your calculations. You only round your answers at the very final end. So your very final answers, when you round it, you don't round in between. If you round your calculations, you notice how I did it? I rounded this one. By rounding this answer, that's not the full answer, that's an approximated answer. Because that's an approximated answer, you will get an approximated answer here. So how do you make sure you don't get an approximated answer? Ideally, you type all this in one go. Okay? But if you don't type it all in one go, then you need to take as many digits as you can from both sides to make sure that you get the best answer you can get here. So at year 12 level, when your calculations get really big, ideally you want to use exact answers and not approximate. Okay, so the best way to do it was to actually type it all in one go. So 7.2 times 7.2, that's the square. Take away, and you actually then type in, pi times, what was it again? 7.2 to the power of 2 times, and it was 90 out of 360. See how I get the same answer? So that's the difference. Instead of breaking, a lot of students on their calculators, you do it step by step, which is great. But what happens is you get up to this step, when you're using a rounded answer. Had I asked round to 6 decimal places, you guys would have had 0, 0, 0, while someone else would have had many more different digits. That's the difference. Okay, so just being careful with your calculations. Make sure to take as many decimals as you can, or do it all in one go. Okay, and to do it all in one go and to calculate correctly means the symbols you use, BODMAS is important. Okay, and that's why I use brackets in my calculations. So if you don't do brackets correctly, you can screw up with your calculations you're calculating. Yeah? But that's just something to think about if you're pursuing mathematics at the higher level later on. Those details matter. Yeah? All right. Other than that, that's it for today's lesson. There was only one rule, one formula. At a year 8 level, area of a circle was equal to pi times radius squared. I only added on that extra times 0, 360. Okay? All right, team. That's it. I'm going to